Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, I'm back on the Panasonic WV-5370 CCTV monitor, a little cube monitor. I worked on this recently in a video on the second channel where I took a look at this plus 3 other CRTs. And this is what I really came up with this monitor. So it's got dirty pots, it's filthy, it has a dirty power switch which is fixed and actually isn't really fixed with contact cleaner. It came back to life for the last video, but it didn't work again, so I had to redo it with contact cleaner. But I think some deoxit in there should help it stay working for a little while longer. Back to the note though, the biggest problem is this, worn CRT with back ears. Well, let's talk about the worn CRT first. Let me get the camera situated so you can see how terribly worn out this poor old CRT is. I have the camera set to manual focus mode, and it's actually kind of funny because I can't use the focus peaking feature on the camera because the screen is so blurry. So this little CRT, which is a 9-inch CRT if you compare it to the size of my hand, I found this thing in the trash. It didn't work. The power switch, as I mentioned, was not working at all. But I think this thing is also just completely worn out. The thing was totally filthy all around, including on the CRT. There's a bit of a clean spot in the middle from the last video where I just tried to clean it to see if it was a little better, but it's not really better. The only way to get a picture that's even remotely usable, like what we're looking at here, is to have the contrast maxed out. It is all the way up. I mean, the pots are dirty as well, but yeah, and it's quite dim. I know in the camera it's gonna look okay, but really, to my eyes, I know how monochrome CRTs should look, and this thing is very worn out. There's a brightness control as well. I mean, that's completely maxed out, and yeah, it does not look good. Now, if I turn it way down like this, now we have a pretty sharp image, and I can actually see on the camera the focus peaking is actually working now, but it's incredibly dim, and that's not particularly usable. So what I really want to do in this video is get this monitor cleaned up, but also swap in a different CRT, one that will work a lot better than this. And what I'd written on the note is that this CRT has back ears. Now, what does that mean exactly? Now, when I say back ears, what I'm talking about are the mounting tabs that are on the implosion band. That's the steel band that goes around the perimeter of the front of the CRT. These mounting tabs or ears can either be on the front side or the back side. Well, they can also not exist at all. And in that case, there's a kind of metal band that goes around the CRT and it screws into the bezel, and that's what holds the CRT in place. But in the case of this particular monitor, these tabs are on the back side. Now, this is the opposite of the way the 9-inch Macintosh CRT is. Those use these tabs on the front edge. And it's unfortunate because I have a few of those that are surplus. They came from battery-bombed Macs or sources like that. And that would be perfect to swap into here. But of course, if I mount a front ear CRT into this, the entire CRT is going to be set back maybe 2 or 3 centimeters, which that'll obviously leave a big gap on the front bezel, so that's not really going to work. Now, all is not lost. Because I'm a bit of a CRT hoarder, I happen to have this CRT here. Green 9-inch CRT with rear tabs. Yeah, I've taken to start labeling the CRTs that I have stored in boxes like this and putting whether the tabs are on the front or the back, because I know that makes a big difference. And if I'm going to be looking for an appropriate CRT to swap into something like this monitor, well, it matters if you're looking through a bunch of boxes to be able to go right to the ones that has the right tab. So I found this in my storage unit. I think I might even have one more of these, but both of them are only green, which is kind of unfortunate. I'd like to swap a white CRT into this, like a P4 phosphor, which is what this is. But unfortunately, I'm limited to what I have. So a green 9-inch CRT, well, hopefully that's gonna fit and work in here. Right, so before I actually swap this, I'm just gonna look at a few other test patterns on my test pattern generator here, just to see, you know, what it really looks like. You know, it's funny, now that I've run this longer, because in the last video, I didn't run this more than a handful of minutes, the CRT is waking up. I gotta say, it is waking up. It doesn't look nearly as bad as it did before, although, oh, this has some serious burn-in. Let me clean the CRT here so we can actually see the burn-in. I was like, what's this line going across the middle? I think what that is some absolutely insane burn-in that this thing has. Yeah, whatever this was showing. Let's try to clean this up a little bit. It is very dirty, everyone. It is very dirty. So here we are displaying a full white field. Look at the burn-in. It's odd that This area and that stripe there are less burned in than this area down there. Typically, any of the brighter areas that were displayed on this thing for years and years and decades, or however long it was used for, those are going to wear out first. And the things that display less are going to be actually brighter, which is this area. So this must have been, well, maybe this was a camera that was shining out into, say, a backyard or some public space. And this area here was bright, like maybe this was daylight, and this was under a roof. And maybe, I don't know, there were some wires here or something like that, so that this area up at the top was always dark. A lot of times there would be some on-screen displays to say, like, you know, camera 1 or backyard. I don't see any of that on here. Yeah, it just has some splotches and stuff like that. Now, this thing was obviously used for its intended purpose. This was really targeted towards people using these things hooked up to security camera systems. And that's what this thing was obviously used for. And it's actually kind of amazing to me how reliable these things are, because look, this thing just works, except for the power switch, which is dodgy and dirty contacts and stuff. But otherwise, how many hours could this thing have run for to get this burned in? And yet it just works, just still works. It just needs a new CRT and then it should be as good as new. Now, I really like these small security camera monitors because they are perfect, because they're very high resolution. They're perfect to be used with 8-bit computers. And in fact, Apple, when they were first marketing the Apple II, the original Apple II that is, they didn't make any monitors. And it wasn't until they had Monitor 3, which is what, like 1981, that Apple started, well, contract manufacturing with, I think it's Sanyo maybe, to actually make that Monitor 3 that then you could pair with the Apple II. Well, the reality was all the earlier computers that were sold, you had to use a monitor like this. And in fact, a lot of their press images showed Sanyo, I think it was a Sanyo CCTV style monitor used with one of those machines. Because at the time in the late 70s when the Apple II was released, well, this was really the only way you could get really sharp composite video monitors. Hooking up an Apple II to a TV, you're really not going to be able to display 80-column text very well. But even this small 9-inch monitor will have zero issues resolving 80-column text. And I know this thing is from 1990, so it's not like this is super old. But electronically, I think there's really no difference between this and the much older ones from the 70s. And those things also would be super sharp. So these are ideal for that, but they're also small, they're portable, they're stackable. That's why I love these things. And well, with that green CRT that I'm going to swap into here, I don't necessarily mind because, hey, we all know that green CRTs and 8-bit computers kind of go together. They're hand in hand. So I think it's an appropriate swap, and it's also the only thing I can do because it's all I have. So before I take this thing apart totally and get this CRT out of here, let's hook it up to the Apple IIc here so we can see the way the text is resolving, because the problem with it being burned, the burn-in is not the worst of the issues. The issue is I have to turn the brightness and the contrast all the way up to get any kind of usable brightness out of this thing, which overdrives the CRT. It will just cause it to become really blurry, and no amount of focus adjusting is going to actually make that better. Now I'm realizing here, even with the signal disconnected and the screen is just totally black now that I've cleaned the glass, the burn-in is super visible and very apparent. So this poor monitor, it worked hard its whole life. It really worked hard. All right, there's the Apple IIc plugged in. Oh boy. Well, that looks pretty terrible. Let's turn the brightness down. Okay, so, I mean, if this is all I had, it's certainly usable. It's not like this is totally useless. It's just not sharp. It's sharp if I make it super dim. That's fine. Even that's not that sharp though either. But turning this up so it's usably bright, yeah, that looks poor. Let's switch to 80 columns mode and see what this looks like. Oh yeah, that's abysmal, absolutely abysmal. Let me get you closer in. I have to use something else to focus on so I can get this in focus because it's so poor. Yeah, that looks really bad. There's a bar here, that's from the camera. That's not actually in the CRT. Yeah, that just looks bad. It's just poor CRT. It's just been used up. Its life is gone. And let's switch to the diagnostics mode. Yeah, it's just very soft. You can just see the blooming. You notice when I turn up the contrast how, oh, it's out of focus a little bit. Oh, there it is. So notice the edges, they kind of expand outward. That's called blooming. And when you turn it up so it becomes decently bright, everything is blooming really bad. But yeah, you turn it down and I can start to see the scan lines now. So it's sharp. This monitor, or the actual electronics in here, has the ability to resolve the actual resolution and the scan lines and everything. It's not a failure, sorry about that, it's not a failure of the electronics, it is totally a failure of the CRT itself. It's an analog device, it's being overdriven, and when you overdrive it, it gets blurry, it blooms. It's just what happens. Okay, so with that said, I think what's left to do now is turn the power off to everything and take this thing apart, and that'll give me the opportunity to clean it properly and then swap out the CRT. So that's what I'm gonna do. Let's move the 2C off the bench, make some space. I don't think there's really anything to fix on this thing. I don't think even any of the caps are bad. And this is from 1990, and caps were getting kind of junk at that point, but yet this thing seems okay from that perspective at least from what I could tell by just looking at that. Now, a few things to talk about with the design of this. Obviously, the top lid is already off. I just never put it back on after working on it in the last video. So, interesting thing about this set is structurally, it uses the top cover to really keep structural rigidity. The back cover is a separate piece that is currently unscrewed. It does screw into this bottom chassis. The CRT itself is connected, well, I think I was looking at how this is built. So this warning tag here, it's kind of silly. It seems like the CRT itself is actually screwed into the plastic bezel. And I assume the bezel is connected to the bottom metal chassis. So sometimes there's like a metal loop that will go around, and that's what the CRT is attached to, but no, it's just attached to this plastic here. So you really do need that top cover, which gets screwed in on the sides and on the back to really give this thing the strength so you can stack it with a whole bunch of other monitors and stuff like that. And without the cover on, you certainly don't have that strength. So first off, I'm taking this little tag off because it's kind of annoying me. Because it's actually kind of hard plastic. And yeah, it's just a warning. It says that the picture tube employs implosion protection. Replace with tube of the same type for continued X-radiation protection and safety. High vacuum tube. Picture tube is dangerous to handle. Refer servicing to qualified service personnel. So yeah, along those lines, obviously this thing is going to run at like 10,000, 12,000 volts, something like that, through the flyback into the high voltage anode connection there. So you really only should be working on these if you know how to do so safely. If you are not sure of how to do it safely, then do not work on a CRT like this, especially if it's connected to the mains. Now this one has a transformer set, so this comes in, goes through the transformer immediately while it goes through a fuse and stuff over here. Then it goes into this transformer. I don't know what the voltage output of that is. It's probably something like 15 volts or something like that, and then that's regulated down on the set, because one thing that's cool about this, and we'll take a look at it when we're done, kind of explore what's on the back there, because there's some switches and stuff, but this does support DC input as well. You can run this off of 12 volts directly, which I hadn't actually tried yet, but I'm sure it does work. So this could be theoretically used in, say, an RV, like a recreational vehicle, as a reverse camera display. And I think I've seen RVs back in the day that use stuff like this for that exact purpose. Okay, first things first, I am going to discharge the CRT, or measure the voltage on the CRT using my little B&K voltage probe thing here. What you need to do is clip this onto the DAG ground, which is the spring that goes across the CRT itself. And then we just need to get this underneath here, which is very dirty and crusty. Ooh, there we go. And there's nothing. No voltage. So some sets, like this one, they probably discharge, self-discharge when you turn them off. You kind of hear it with a little bit of static, you know, noise when you turn it off. That's the discharging happening. But not all sets do that, so you don't rely on that. That's why you want to use something like this, or, you know, screwdriver under there hooked up to the ground works as well. So that gives you an idea of just how dirty this is, because this has been run so long. Look at that. I got to get gloves. My hands will be super dirty if I don't. Gloves have been applied. Wow. So again, I'm just going to use a little bit of Windex on here just to make it so I can touch this without it instantly making my hands filthy. So to get this off, I'm just going to use a little plastic tool here just to reach underneath and unhook it. Now, one thing you need to keep in mind is this is a large capacitor, the CRT, so unhooking this, well, a charge can actually build back up. So I'm just going to check that. There's nothing measurable on here. I know you couldn't see that when I touched it. It didn't actually measure anything. But you can get a little bit of a shock if you touch this, even if it's been, you know, unplugged from the high voltage for a while. Okay, so one thing that's really annoying about the design of this thing is that the power cable is going through a cable gland and it's connected directly to the board and it's soldered on here. There's no connector. If they had just spent 50 cents and put a connector there, or spade connectors, you could have taken this cable gland off and actually fed the cable out and through the back of the set. And unfortunately, that's not possible. So I have to just sort of work with this stupid thing on here. Now, I guess what I could do, actually remove that cable gland, just slide the cable in so I could at least have this metal plate further away. Maybe I'm going to do that. Yeah, because I just got to kind of figure out how to get this thing apart. So here's the cable gland tool. People ask about this. Pros Kit CP311. This was sent in by one of my viewers, and this is a really easy way to get these cable glands off. Just squeeze this. Oh no, there it is. Got it. There it is. Okay. So just took a little bit of finagling, and then I can just take this little cable gland off like that. And now I can feed the cable through. So now I just need to get this stuff off, and then I can properly clean this back cover as well. Not much to these rear controls. There's just a set of screws. Oh, that reminds me though, I was asking about the fact is if this thing has GIS screws on it or not. It's made by a Japanese company. Well, it's Panasonic branded, which is Japanese, but it was made in Taiwan. And I guess my question was to people is, would it still be using GIS screws? And people thought that it would indeed be using GIS screws. Okay, well, the greatest hits just keep coming. It appears that the BNC jacks on the back, they're actually like soldered on. Like they were put on the back cover first, and then this board was attached, and then the connections were soldered. What the heck? That is just unfriendly. I don't know why I'm bothering, but I just like to kind of I need access to these switches. I need to clean that stuff because everything is just filthy looking here. Okay, well, while I wait, because this has to warm up, just kind of looking at things. So we can take this off the CRT, the little neck board that it's got. So there it is. It's all very filthy, so I'll have to clean that up a little bit. There is a little tiny cap there, but I don't think there's any cap problems on here. I really don't. We only have to worry about caps that are right near things that get very hot. And while there's a heatsink here, so I'll look to see if any caps are right next to that. But generally all the stuff that's over here is probably fine. Nothing's leaked or anything. So, okay, let's see if I can get this off here. Okay, whoops, there. Just fell. So now with the cable gland off, I can slide this down. So this is what I was talking about. This metal plate is here, and then the actual two BNC jacks are actually, the nuts are on the back side. So that doesn't come out. I don't understand the design here. This is not friendly. I'm noticing here there's actually a provision for 4 BNC jacks, although this metal plate doesn't have those positions there. But you know what? I don't really like the BNC jacks, not for my uses. I will be using this with a computer. So I'm definitely going to add a regular RCA jack in here. And maybe those are perfectly good spots to do it. It actually appears to me that there would have been an extra toggle switch. Yeah, there's a spot for another switch here. And it looks like there's an external sync input. It says sync, or the switch is not populated, and that's would have been what those are for. So there would have been an extra resistor or two somewhere on here that would have fed back into the board and let you have that external sync signal. DC restoration, there's sync. There's a jumper link right there, and then horizontal AFC. Now, interesting is there is a switch right here, switch 2, for sync internal or external. But according to this, it's external, internal sync, or long and short. And I think we look at the back here, cable comp, short and long. I don't know what cable comp is, but that switch can either be cable comp, long or short, or external or internal sync. Anyways, now this board's off, I'll be able to do a little bit better cleaning inside those switches because they're all pretty dirty as well, just like everything else is here. Just a lot of dust and dirt on everything. Okay, so now we have the CRT. I got to get this thing out of here. So first thing we got to do is we got to remove the deflection yoke. Then I should be able to just loosen these fasteners and take the whole thing out. It looks like there are 4 or 2 fasteners that hold the bezel onto this bottom metal chassis. And they're behind probably a sticker that's on the front here because I could see the back of the screw sticking through, but there's no screw head on the front. So I'm not probably going to take that out, although I may need to. oh, I'm noticing, everyone, you can get to the PCB to service it. There's a metal plate on the bottom which we can take the screws out. I see 2 screws there and there's 2 on the other side. And I think there is, yes, there's a bottom plate. Okay, this might be kind of annoying because I do want to kind of get that out to really get to those pots on the front to clean those out. But first things first, let's get the CRT out of here. And the deflection yoke is, of course, the wires are soldered onto the board as well. There is a connector for this back panel, however, so I am noticing that, and for the video connection. Okay, so I didn't necessarily need to take this off. You can move the back panel by just unplugging these connectors. You will have to cut through some of these zip ties that are on here. But it looks like the video signal that makes its way through this little coax cable just plugs in the board right there. Okay. Well, anyways, the rest of these cables, though, that go to the deflection yoke, they are permanent. So let's get the deflection yoke off. So I'm going to loosen that fastener here. And then I'll just grab it and turn it. There's a bit of like what looks like hot glue there, but that is actually not holding this on to the set. So that just turns very freely. You just carefully get this off. Like so. And our deflection yoke looks good on the inside. If you see any corrosion in there, you got problems. If we don't have any corrosion, I think we're in good shape. Right, so now we got to get the CRT off. And what I'm going to do is just loosen the fasteners first without taking any of them off. And I think once the CRT's out, I realize that I can then gain access to the pots very easily. So I'm going to take this outside and really hit it with contact cleaner, because I like to use that stuff outside if I'm going to be really spraying a lot of it. The QD electric cleaner stuff. But anyways, yeah, I'm going to loosen these fasteners. Yeah, you can pretty much get to all of them without having to take this thing fully apart. So CRT swaps, relatively easy, even though this thing is not the best from a service standpoint. One thing I'm noticing is there's no particular wire, like a ground wire, that goes from the spring to the neck board. So that means there's a black wire here that's probably ground. And I can see that the metal chassis right along this bottom edge, see how there's like a little ground strap right there? So almost certainly the CRT grounds to that. And then this is what grounds the main board. And then that grounds this neck board. I kind of like it if it's a wire, so you're not relying on an extra ground strap that someone might forget to connect. Well, it is what it is, and that's just the way that this thing is designed. Okay, so the spring is hooked on the bottom here, but on this top side, it's on the screw. There's like a little clip that's screwed in, so now I'm going to carefully undo these. And the CRT will fall out, so you have to be careful and ready to grab it. And of course, all that's holding the CRT up is plastic, so I'm trying to be gentle. So I'm going to hold the CRT in with my thumb. And I know you can't really see it, but I'm getting this side out, and this spring is going to spring. So I'm holding it as well. Whoops, there is the spring. And now the CRT is actually free. So let's pop it out carefully. There it is. There's our CRT. With burn-in and everything. We looked at this on the last video, but there's the part number M10908P4AU, P4 being the phosphor type. And this is that company. It's a Taiwanese company that makes these CRTs, and they're good quality. I'm not sure if this is Clinton. If it is Clinton, then that's what's in a lot of Macintoshes as well. And you'll notice this tab, this little copper tab, it's underneath this tape. So there's this friction tape that's underneath the implosion band, and that loops around underneath the tape and is touching this matte texture here. This is the aquadag, sort of the ground of the CRT, and it's looped around and it's under this metal band. That way this band is now actually the ground point too. So these tabs are grounded. Now, this thing itself actually has mounts that the CRT screws into that are plastic, so that's not grounded. So that's why this is using this spring here, which is connected down here to the chassis. So that is the CRT ground. And you have to have this spring in place on this particular design. Otherwise, you would need to have just a wire that goes from one of the ears down to the chassis, like onto this screw point, and that would work fine as well. That's kind of like how the Macintosh does it. All right, so this is what I was talking about. Now that the CRT's out, we have access, which is out of focus. There we go. You have access to all these pots. There are a couple small pots. There's underscan overscan switch right there. That's probably really dirty. And then we have our power switch that has had issues already and not working. So that's something I'm going to have to really hit with a lot of contact cleaner. And I think what I'm going to do is take this outside and get the contact cleaner and really just, well, first I'm going to blow off the dust that's on here with compressed air. Then I will hit it with a lot of contact cleaner and I'll try to clean it up a little bit. And I think I should be able to get this thing looking a whole lot better than it looks now. And hopefully with the contact cleaner working a whole lot better than it does now. Well, you know, with the scratchy pots and stuff. Okay, I'm back from outside. It's cleaner. It's not perfect because I didn't really do a full wash on it, but all of the switches and the pots got cleaned with this stuff first, QD electric cleaner. So the pots on the front all turn really easily. And then I finish it off with some of this Deoxit Fader Lube F5. So this is plastic safe, so it won't destroy anything. And it really leaves a nice coating on everything so that the lubrication is brought back to the switches. This stuff washes away any of the actual lubricant that's in there and the pots and stuff on the front. Now it should be hopefully more reliable. And I also cleaned up a bunch of the wires. I really lubed up the power switch. I even cleaned, for instance, this thing so that it's not so dirty to touch anymore. I mean, it probably still is a little bit. You always run the risk, of course, when you're cleaning stuff like this, that you cause more damage and break something. So hopefully I didn't do that. But I also took this time to kind of inspect and see if there's anything that looks out of the ordinary. And everything looks actually pretty good. There is one diode over here by the power switch that obviously has gotten hot. The PCB is discolored. So that might need to have its solder joints checked on the bottom. I haven't really actually looked to see what it's like to take this bottom panel off. See, there's like one screw there that kind of goes into this transformer bracket, plus 4 fasteners that look like take this bottom panel off. So I think it's actually going to be possible once we get this thing working with the new CRT to take the bottom panel off, and then I'll just check and reflow any of those joints. Okay, well, I think at this point, I want to try to get that new green CRT in here because, of course, this will be a dead-end video if I can't get that new CRT in here. So this is the green CRT, and I think this came from an Apple IIc monitor. A viewer sent one in that was all damaged, like the case itself was cracked beyond repair, but the CRT was still in good shape, and there are 2 types of Apple IIc monitors. One type has the backwards facing ears and the other one has forwards facing ears. Well, as you can see, this is the backward facing ear type. So it does not work in, say, a Macintosh, and this is a Hitachi tube. And I think this is gonna work in here. I hope at least. It also already has the spring on here, so I should take this off because that is redundant since this chassis already has one of these springs on it. Other thing is I'm noticing there's one plastic clip on here. There's like a washer or something. There we go. That was obviously from the Apple IIc monitor. Does this fit in here? Oh, I don't even know if this works, guys. This may not work in here. Why? I think this is actually a failure. I don't think this CRT fits in here. And the reason why is there's these like plastic spacers on the bezel here that kind of space the CRT. And they are, or I'm gonna have to trim these. Okay, well, this didn't quite go to plan. So this is the green CRT on the right. This is the original one that came from this monitor. This one appears to be slightly smaller than this one. This one is actually freaking larger. The neck of the CRT actually seems to stick back a little bit further. It's the same connector, so there won't be any issue with compatibility, but yeah, it sticks out a little further. So it might hit the back of the monitor. I don't know about that. But that, unfortunately, is not the biggest of my problems. Let me see if I can get the camera adjusted so you can see a little bit better what's going on here. So it kind of appears that the mounting tabs on the green one are actually further forward a little bit, at least based on the front curvature of the glass. Meaning with these both sitting on 2 sheets of bubble wrap, it's about, I'd say, 1/2 centimeter more forward on the green CRT. And that means if I mount the green CRT in this chassis, if I could fit it, there would actually be a gap between the bezel and the CRT itself. So that's one problem right there. But the much bigger issue, the green CRT is bigger. I thought these were the same size, but if we hold these 2 CRTs next to each other like this, I need to be careful not to break anything because the green one, of course, is the one I care about. The other one will just be recycled because it doesn't necessarily matter. Let me just get these standing next to each other. Without a doubt, the green one, hopefully you can see that, it's actually bigger. And that's why it doesn't fit inside the front bezel. It's like hitting the little plastic things that are there to align the CRT. So that means I can't really use this. Now, I had this exact CRT in a Macintosh and it worked fine. I had some spacers set up because if the chassis is designed for front tabs, you can just use a little spacer, and if you make one that's the appropriate size, then that'll work fine. I don't recall it not fitting, but clearly there's a difference in size here. Now, I guess what I need to do is grab a Macintosh CRT and I need to compare this as well, because what if this one that came out of this Panasonic is just smaller than the Macintosh one? Then we're sort of stuck, and I guess I'll have to start physically modifying the front bezel to maybe make it work, maybe. Okay, here's our rusty CRT. This is the one from the Mac that I found that was all rotten inside. CRT works good though. Let's see about these. Oh, same problem, everyone. Same freaking problem. It's bigger. Wow, I just didn't realize that there was a smaller size. So, okay. Yeah, it's bigger in exactly the same way. I mean, the height, you know, this standing on the long end like it is here, probably not that easy to see in the camera, but I'm gonna say that it's at least an extra centimeter taller on the width side. Okay, well, let's see if I can, even though this is the rusty one and it has the wrong tabs, will it even remotely fit in here? No, this is actually a lost cause, everyone. Oh, I'm so disappointed. I'm so disappointed. So the reason for me saying it's a lost cause is that just from the width perspective of this 9-inch CRT, it's too wide to even fit in here. So just placing this Max CRT in here, like the tabs are extending beyond the edge of the actual like chassis, because we know the metal is right there. I will either have to extensively modify things like cut down the ears on the CRT, which, you know, now that I think about it, I remember working on one of these security camera monitors, like one from the late 70s. It was a Toshiba medical imaging one, and the tabs had been sliced and cut down to size so it would fit inside the case. It feels like that's a similar situation to like what's going on here. So what I can do is I could remove all these extra tabs that are on this plastic bezel entirely, and then maybe the Apple IIc one will fit in here. I don't know, I'm gonna think about this for a second, because I'm not worried about modifying this thing. This thing is kind of trash. I found it in the trash. If it doesn't work again or I can't use it, then no big deal. It served its purpose. But if I can make it work, then that makes me extra happy. So I think what I'm gonna do is I'm going to cut away at all these plastic tabs that are all the way around this thing, including these on the bottom here. I'm gonna slice these away, and I'm gonna try to get the CRT mounted into here and see if it can fit. And if I have to use a Max CRT, I'll cut these things here, these posts. I can take off like a lot of these, and I just have to use a very short fastener to hold the CRT in, and that should work theoretically. I mean, if I have to, I'll just hot glue the whole CRT in there. I don't know. Let me try to get creative. I have nothing to lose at this point, nothing to lose. Well, after much yelling, swearing, hacking, all those things, this is the 2C CRT, and it is in the set. Now, it's not screwed in. There's a whole bunch of plastic here that I had to cut away. The problems are numerous, but I think what I want to do at this point is I want to at least hook up the high voltage. I have the yoke and the neck board connected. I want to see if this thing does work properly. So because I have the BNCs not connected, I have soldered on a little RCA cable onto the input jack, or input board that is. And one of the big issues right now, if I carefully turn this around, is that there's a sizable gap between the CRT and the bezel. Now, I don't think this is insurmountable, as I mentioned, because it is squished in here. Now, it's bowed out ever so slightly on the edges here. I don't think that's a big deal. I can bend the metal case if I have to kind of make it all fit. And if I want to get this thing to be flush, the CRT with the bezel, I just need to cut off whatever this gap is here. Let's see if I can figure that out. I can with this. So I'm going to say, based on the little pokey part on here, that we have to remove about 6 millimeters from the plastic here. So I can just Dremel that off, 6 millimeters on the posts, on each 4 of those posts, and then at least this thing should sit flush. Now, if I ever try to go back to an original CRT that was for this, which I never will, because I've never seen a smaller CRT, I don't know where to get one, well then I'd have to put spacers. But I'm not going back to the original because I don't have any of the originals. I'm sure any of these monitors that have the original are just completely worn out, so there's just no point. So 6 millimeters and, you know, a bit of a bent up case. I mean, we'll have a perfectly bright green CRT. I think that's a worthwhile exchange. But we need to see if this thing actually works. So first things first, I'm going to connect up the high voltage anode cap. And I will say that the CRT itself is not even screwed in right now. It's just like friction fit. In the short term, not really a problem. In the long term, I'm just going to have to modify the posts, and I will need to modify the ears. I'm going to have to cut away a little bit of the ear, so because the holes don't even line up at all right now, just because this is so much bigger. Anyways, okay, so the little board back here has a little piece of paper to keep it from touching. Yep, just making sure it won't short against the chassis. We have the RCA cable, which I will plug in a sec. In fact, let me just do that right now. So I have a little coupler device, so I'll use this. All right, let's do a double check here. I'm using these clip leads, by the way, because the spring is not on, since those screws don't work right now. Once the screws go back on, then I won't need these clip leads. So the clip leads clip from the CRT tabs or the ears to the metal chassis. Neck board, deflection yoke. I have the RCA, the signal inputs hooked up. I don't know, I think we're actually ready for testing. So I'm going to turn this to the on position and watch the LED. And here we go, 3, 2, 1. Okay, we have high voltage. I hear it. Okay, and everything is turned down all the way. Aha. Oh, there we go. Switch the input to something that we can see. All right, there we go. Okay, well, it looks like garbage. Absolute garbage. What did I do? It's some of these switches on the back, maybe they need to be fiddled with. Let's see here. That one didn't do anything. How about that? Nope, still looks like garbage. Oh, that must be the frequency control one. Okay, so what's really weird is we obviously have it working, but where's our nice smooth gradient from light to dark, right? It should be there, and it's totally not. So I'm not sure. I actually couldn't tell you what's going wrong here. This is unexpected the way this looks. Okay, wait a second, I just had a thought. I did adjust some of the other controls while I was cleaning them. For instance, let's see about this one on the neck board. There's one on the neck board. So I'm using a plastic tool to touch this. What is this one? This is like a sub brightness control, I think. That's with it maxed out, and it still looks like garbage. Yeah, so one thing that's not working is I would expect the brightness control to be like the screen control. And I should be able to turn this all the way up where we should be able to see the retrace lines. But that doesn't appear to be the case. There's one more control in the back, but I think this is focus, and I did fiddle with this while cleaning it. And it is a high voltage control, so you have to be careful with it. Yeah, that is the focus control. So that doesn't do anything to fix the cathode drive. There's something going on with the cathode drive. And I don't think this is necessarily a fault. I just assume this has to be an incompatibility between this CRT and the drive circuit. Well, this is an interesting development and not at all what I expected to actually happen here. Yeah. All right, I'm gonna play around a little bit, see what I can figure out. Well, it's actually the next day, and I think I realized why I think I realized all of my problems. Why the CRT doesn't fit in here, but also why it doesn't work in here, at least this green one. When it comes to the CRT not fitting in here, the main reason why it doesn't fit is I just made an assumption that this was a 9-inch CRT, and it's actually not. So here we are on Radio Museum in the video monitor WV-5370A/G. That's this particular monitor, or at least a variant of it. They think that maybe it came out in 1983. It's quite possible. This was a 1990 model, but these things were made for a long time. There's no schematics here, unfortunately. And it looks like the one they're talking about, the variant, is a 220 volt one, but that it doesn't really matter. But that's definitely our monitor. But if we look down here, picture size, about 8 inches, 20 centimeters. Well, with just simple math, we know that 8 is smaller than 9, so the 9-inch CRT doesn't fit in the 8-inch CRT monitor. Anyways, I guess I didn't realize that 8-inch CRTs were a thing. And when you Google for the part number of this set, you really don't find anything except for this result and a few other kind of search engine optimization results. No specs, no brochures, no information really about it. And I just made the assumption that it looked like a 9-inch CRT, and I've seen so many 9-inch CRT displays in my limited experience, albeit, and I didn't realize that 8-inch was a thing. I bet people watching when I was comparing the two CRTs next to each other were saying, yeah, that's an 8-inch CRT, duh. Well, I have never run into an 8-inch CRT until today. Well, anyways, with enough brutality and removing of plastic from the case, I was able to fit this 9-inch CRT into the case. And yeah, I would have cut off a little bit of the edges of the bezel. And actually it fit within the depth of the case as well. If I put the covers on, it would have been okay. It's really just the problem of the CRT not working now. And I think I've realized why that is as well. Thank you to Andy over here on Bluesky, because I posted a little bit about this monitor a few weeks ago, or about a month ago actually, and Andy pointed out that schematics were available on archive.org for this particular monitor. And here they are. So it's not exactly this monitor because it's the 5350 and this is a 5370. I've reviewed the schematics and I've looked at the way this monitor is, and it definitely seems like the 50 and the 70 are essentially identical. Maybe there's some slight differences, but I don't know what those are. Now take a look at the schematics. For the 50 variant, there is the CRT itself, and H is the heater, so that's what warms up, 12 volts. K is the cathode. Typically, you drive the cathode to actually generate the image. That's like where the emissions are coming from. And then we have grids, G1, G2, and G3. And as far as I'm aware, G3 is actually G4 on these monochrome CRTs, and I don't think there is a third grid. But it doesn't really matter. It's the last grid, the one closest to the CRT, is used for focusing, and that is the case on here. See, it goes down to the focus pot. Now G2 on most CRTs, like color CRTs, is used for the screen, and that's to kind of control the overall brightness of the image. Now CRTs are really just vacuum tubes, you know, with a big bulb attached to them, and that has the phosphor and the electron beams and stuff like that. So there's a lot of analog magic that's happening inside of these things. And the various grids and the cathode, they all need to be biased a certain way and driven certain ways. And I think the fundamental problem that's happening right now on this monitor with this Apple IIc CRT is that this CRT, well, it just needs different bias voltages and different grid voltages for like cutoff and stuff like that. And I think the problem is the electronics that are on this monitor don't generate the appropriate bias voltages and grid voltages to actually allow this CRT to work correctly. We saw earlier that it was able to produce an image. There was sufficient high voltage, and obviously the grids and the cathode were driven in a way that could at least produce some light, but we had lost all of that grayscale. So in other words, from light to dark, instead of having a nice range, it was all compressed really into a tiny little thing. And I think that all has to do with the way the CRT is actually being driven by the electronics. Now looking here, we can see the heater stuff's all pretty standard. We know that the grid 3 or G4 for focus, that's pretty standard, but it's where the cathode and G1 and G2 come into play. Now the way this monitor works, and it's kind of annoying because this schematic split over 2 pages, but well, if you look at G1 and we follow the trace, it goes back into this section of the schematic. You can see there that there's an output transistor, which is almost certainly the final stage in the cathode drive circuit. And we have to go up here to look at the rest of this diagram. So there's that same transistor, and you can see that it makes its way through a whole bunch of transistors all the way to the video input. So without a doubt, that is the cathode drive. The contrast control on the front of the monitor and the brightness control are through that chain itself. So that's one of the reasons why I think when I turned up the brightness control all the way, I wasn't seeing the retrace lines. That's simply because that's typically controlled with the screen control on most monitors. But on this one, it is not controlled that way. Now, if we go back to our other page, so there's our neck board. Well, G2, if we look at G2, actually goes down into this part of the circuit here called cathode clamp. So G2 goes there, and so does the cathode. Both of those things go into that section. And we do have the little resistor that's on the neck board, or the variable resistor, and that's the sub-brightness control, VR201. And in a way, it's actually that control, which is more like the screen control, because that is wired up to G2, G2 being what would typically be called screen. But the cathode itself is interesting because that's also connected to this circuit, and none of this is actually hooked up directly to the cathode drive. So the video signal stuff, all that modulation of the video signal is actually happening entirely on the G1 or grid 1. Now, I'm not sure that necessarily matters, because if you have the cathode just outputting like a constant stream of electrons, and then you use the grids to modulate that, I guess that's perfectly acceptable. I don't know a ton about this whole analog circuit design of CRTs. I mean, I know enough to kind of troubleshoot it, but generally when it comes to the design and getting all these parts just right so you have a great, sharp video signal, that's a bit beyond my expertise. And I think a lot of people, unless you've been fixing CRTs for a long time, a lot of this stuff is just sort of analog magic, so to speak, that was well understood in the old days because there was lots of people out there who studied CRT theory and had read books on this and taught classes on it. But a lot of those people are retired now or not with us any longer, so I think this knowledge is sort of fading away. Now, the G2 voltage itself is not actually controlled by this variable resistor. This is entirely changing just the cathode through this transistor. So the variable resistor is altering the base on this, and as that transistor turns on, it is going to connect to the cathode more and more to ground. Now on a CRT, I do happen to know when you ground the cathode, that is full intensity. And then when you bring the cathode off of ground to a positive voltage, that actually mutes it or turns down the intensity. Well, if you look at this thing, there's a little arrow. Let me zoom in a little bit. There's a little arrow right here that says 82.4 volts. So that's the voltage between 82.4 and 0 volts that the cathode is able to be driven at. Although actually there is this extra connection here through this resistor, 5.6K, that makes its way down to the flyback area. And that's on this connection 7. It doesn't tell us what voltage that should be necessarily, but we can see the cap that's on there is a 160 volt cap. So it's not going to be anything, more than 160 volts. It's probably going to be more like 130 or 120 or something like that. So that sort of tells us the cathode can go between ground-ish and probably 100 something volts or 82 volts or something like that. Now, I think the main problem with this CRT, though, the way it's being driven and why it's not working properly, is specifically the screen voltage, and that's G2. Now, the grid 2 or G2 makes its way, over to this section, but that's really just a power, and then it goes down and it goes right to the flyback, and it's on this trace here. I have my mouse on it so we can trace it, and that goes to output 6. And I don't know. Oh, actually, there it is, 122 volts. This one has a little pointer to tell us the actual voltage on that line, and we have a 160 volt cap. And what's interesting is, unlike a lot of monitors, like on, say, the Macintosh, where the screen voltage is adjustable, and I'll show you that schematic in a second, this thing is fixed, and it's fixed at 122 volts. So we are relying specifically on G2 to be fixed at 122, and then we're using the cathode to kind of modulate the output strength, and then G1, modulate it as in make it all brighter or all dimmer with that sub-brightness control, and then it's G1 that's actually the video signal that's happening. So again, these are all these bias voltages that are happening. So the cathode's being biased to a certain thing depending on how you set that potentiometer. And then G2 is fixed, G3 is adjustable, but that's simply for focus control, or it's G4 really, and then G1, as I said, is the video signal. Now let's go compare this to a Macintosh driver circuit, and I happen to know with this green CRT, it does work perfectly in a Mac Classic because I've actually had this installed in a Mac Classic and it has a great, perfect image. So here is a circuit design of the analog board from a Mac Plus, and it's close enough because the Macintosh Classic and all the various Macs all have basically the same circuit. I mean, the design might be a little bit different, but the voltages and everything that it runs at is the same. So here's the flyback, T1, that's the flyback transformer itself. We have the horizontal deflection stuff all on the left side here. That's the high voltage output, 12 to 15 kilovolts that goes to the CRT itself. But we have extra takeoffs from the windings on the secondary side of the flyback that generate various voltages that are working on the Mac. One of them is this plus 30 volts, that's 0.8, 0.5 is hooked up to ground, but 0.7, that is our big difference with the flyback on the Mac versus the flyback that's on this CRT. We know that the G2, the grid 2, can never be anything but 122 volts or whatever it is, but on the Mac, There is our screen control right there for the Macintosh. The screen control on the Mac can go between 150 and 750 volts. And I happen to know from this CRT, I didn't write it on here, but I'm pretty sure when I put this into the Mac compared to the white CRT that was in there, I had to turn up the screen control even higher. And it was probably something like 400, 500 volts. And then the CRT starts operating correctly. I think right now what's going on in here is, since the grid is stuck at 122 volts, the cutoff is wrong and the thresholds that it's operating at are just wrong. And that gives us that very compressed video image where we've lost all of the grayscale, while the Mac can replicate that no problem because its circuit can generate voltages up to 750 volts. Almost certainly pin 7 on the flyback on the Mac generates 750 volts. And this stuff here allows us to have access, J2-1, that point that gives us that up to 750 volt screen, which really can allow you to crank it up when a CRT gets worn out and you still get a good image on a Macintosh. Also, the contrast control is right here, which on a Macintosh, I think that's that control on a Mac Plus that's at the front of the machine in SE as well. And that actually outputs -25 to -70 volts. Now that's possible because, of course, the signal that's coming out of the flyback, or the voltage waveform that's coming out of here, is AC. So depending on how you rectify it, using diodes and stuff, you can get a negative voltage out of it, you can get a positive voltage out of it. And I think that's what's going on here. That's how you get these negative voltages. So I need to find another schematic that's a little bit better than this diagram, because this is more like a theory of operation. But almost certainly J2-5 is going to one of the grids, and that's one of the bias voltages, and so is J2-1. So let's just see if that's anywhere in here. J2-5, so that would be grid 1. Okay, which one was that? I've already forgotten. J2-5, grid 1. Okay, so that's the contrast control, or what we would call brightness control on the Mac. That's going to G1. My assumption is the cathode is actually what's driving. Yes, the cathode is the actual video signal. So it's flipped around, where on this, G1 is the video signal and the cathode is used as kind of like a bias. Well, on the Mac, they're using the cathode to actually drive the video signal. G1, that first grid, is J2-5. That's that -25 to -70 volts or whatever it is. And then J2-1, that's going to be the screen voltage. I already can tell. J2-1, yep, screen voltage right there. And then we have focus control. This is focus, J2-3, which is equivalent of grid 4, the closest one to the CRT. So I think fundamentally the problem is here is that this CRT and a Mac CRT, they're just not designed to work in this chassis. This thing is designed for a CRT that has a very low screen voltage, and I guess the bias voltages are just in the positive range. And this CRT and the regular Mac one really needs higher screen voltages, that's G2, and then you need to have those negative bias voltages on G1 for it to really work properly. And that just doesn't seem to be what's happening with this monitor. Now, I've run into the same exact problem before, and it was with the Sorek IQ120. That CRT had really bad cataracts. I thought, oh, I could swap in another CRT. I have a bunch of 12-inch CRTs. I could just pop it in there without an issue. Well, I put a CRT in there, a green one, and it didn't work at all. And it was exactly the same problem. The screen G2 grid voltage for the green CRT needed to be like 350 volts or something like that, and the Sorek could never generate more than 120 volts or something like that on its screen G2 voltage. And that, again, is the same thing. That CRT that was in there was just designed with a really low screen voltage in mind. And I don't know if that's like a difference between a computer grade monitor and a TV grade CRT or what, but I remember I finally found another CRT that was, I think, from an old TV, like an old black and white TV, that I put in the Sorek and it worked perfectly. Now I'm still learning a lot about the screen voltages and what makes one CRT compatible with another, but I've sort of determined now, after 2 experiences, this and the Sorek, that yeah, we have sort of 2 subcategories of CRTs. One set that operates on low screen voltages and lower or positive bias voltages, and another that works on high screen voltages, G2, and negative bias voltages. And that would be like the Mac. And well, seemingly most 9-inch CRT monitors seem to work that way, at least the ones I've experienced. I've swapped a bunch of 9-inch CRTs around between all sorts of screens, like a little IBM 9-inch VGA monitor. I have some other VGA 9-inch monitors that swapped those CRTs out because they were worn out. I've swapped lots of Macintosh CRTs, Apple IIc monitors. They all generally seem to be pretty swappy compatible, but then when I ran into the Sorek with its different voltages and I wasn't able to swap it, that was really my first experience. I'm like, whoa, this didn't work as I expected it. And now this monitor. Now, since it's actually the flyback that generates that screen voltage, like we saw on the Macintosh, it was like at least 750 volts. It's coming out of the flyback. And on this one, it's 122 volts. That means there's just no way on this monitor to get those higher screen voltages. I can't alter the circuitry on here to make that higher voltage. It's just not available on the flyback. We would have to swap out the flyback, which of course, there's a whole magnetic resonance thing and it goes with the yoke and all the other circuitry. It's all tuned and stuff like that. So you can't just swap it out. Even if I found one that was the same pinout, like maybe one from a Macintosh that I could put on here, if the pinout was even correct and fit on the board, I mean, there's so many other variables. I bet you someone who's really good at analog equipment hacking or knows a ton about CRTs, they could probably do it. But I think that's a bit beyond my skill level. So I think at this point, unfortunately, there's really nothing more I can do with this monitor. I think this thing is now going to just be a parts donor. I'm going to take this Apple IIc CRT out, put it back in my box so I can stash it away carefully and preserve it for another monitor where it could be a candidate to go into. And I guess for this thing, if this were like 30 years ago or 20 years ago, it'd probably be possible to try to source a replacement 8-inch CRT for this monitor that wasn't worn out. But I think at this point, they're pretty much all gone unless like someone has them stashed away in a garage or something like that. But why would someone have like an 8-inch CRT laying around anyways? It's like such a non-standard thing. I'd be better off just getting another monitor, one that wasn't worn out. And that's actually what I've gone ahead and done. I don't have it here for this video, but since this was such a failure, I felt dejected last night when I kind of realized all the stuff I was just showing you on screen. And I thought, you know what? I'm just going to buy something. So yeah, I went ahead and I just ordered another monitor. It's just I really need to have one more of these cube monitors, you know, little 9-inch security camera monitors. Plus, I'd like to have more in stock because they break, they wear out. You know, we can have a flyback that goes bad on one of these one day and then the monitor is useless. You know, I could take the CRT out to use somewhere else, but those types of parts, once they're gone, they're gone. So even though this video was, you know, an abject failure, I still consider it a learning experience. I know a couple things. 8-inch CRTs exist. I didn't know that. I have more reinforcement learning about this whole screen and bias voltage stuff, that it is important when you're doing CRT swapping, and I probably should have checked ahead of time just to kind of see what the voltages are. In fact, why don't I do that right now? Let me get the multimeter out and let's probe around and see what those voltages are on this thing while it's running, even though it's not going to be driving this CRT correctly, just so we can know if you have one of these, you need to find a CRT that's suitable that accepts these voltages. Let me grab my multimeter. We're going to look at DC volts. First, we're going to check the heater voltage. I got to plug the monitor back in since I had it unplugged. Where is the cord? I've lost the freaking cord. Oh, here it is. Okay, so let's plug it in. It's the next day. Let's see if the power switch even works. It does. Okay, there's our heater voltage, 11.6 volts. So that's fine. I mean, it's about 12. It's what this CRT would be rated for. So we're looking good there. Let's go to G1, which is the cathode clamp. We're still at 2 volts. The monitor's off right now. Let me turn it on. So that is grid 1. Let's look at grid 2. There's our 116 volts. Remember, I thought it was going to be 122, but whatever, close enough. So that's not enough. That needs to be like 300 volts on this CRT to work properly. And let's go to the focus pot. And this is G4, which is focus. And I have it at ground because I have this pot turned all the way to one side. Let me grab a tool to adjust it. This is the focus control right here on the back here. And it is a high voltage pot. It has potentially a lot of volts running through it. See, there we go. Oh, wow. That goes up to 300 volts. Well, that's sort of surprising. I didn't think we'd have that kind of voltage even available. Now, let's go back to the schematics real quick. So G3, this is the focus control. Focus control is connected to G2, but it's also on ground. What? So how is that generating such a high voltage? It literally is pulling its voltage between a variable resistor between ground and G2. That's it. See this thick trace here? That's ground. And that comes up to the variable resistor for focus, and then it just goes directly to G2. But I measured G2 directly on the CRT connector, and we were getting like 100 and something volts. Where's that extra voltage coming from? I am slightly confused. What is going on there? And again, 122 volts. I mean, this thing, unless it's somehow adding these two together, what's this? What's pin 7 go to? Which we don't have a, that's going directly to the video drive circuit. Is there a voltage? 6.2 volts going through these resistors and stuff like that. Yeah, I don't know. That doesn't seem like that's a high voltage rail at all. Yeah, it's all coming off of pin 6 and high voltage. This is what goes to the anode connection. That's not going to anything. I don't get it. Well, maybe someone can clue me in on why grid 4, G4, had like 300 something volts when I measured right on it, but grid 2 didn't. Like I had the 100 and whatever we'd expect it to have. I don't know. Not sure what's causing that exactly. Anyhow, the main thing with this is that we just don't have the adjustability and the ability to generate those voltages that we need to get this CRT to work properly in here. So as I mentioned, this is going to become a parts set. The CRT comes out, goes back in my storage unit, and I'll revisit this and do a little test and tour of the new monitor that I get. And hopefully the new one that I got has a 9-inch CRT, not 8-inch. The information is scant and really hard to find. I hope it's got a 9-inch CRT. I hope it has the normal forward-facing ears so I could swap in another CRT if I need to. And I hope that its grid voltages are normal and not this low stuff that's on this thing. So that means Macintosh CRTs will be suitable replacements for the new one. So all my fingers are crossed. And as I said, this has been a good learning experience. And every time I work on one of these, I learn a little bit more. And hopefully I've shared that with you and you've learned a little bit as well. And I'm so gung-ho about my swaps, but they don't work all the time. And case in point right here, case in point. Anyhow, that's going to be it for this video. Sorry it was an abject failure, but there we go. Thumbs up if you liked it, thumbs down if you didn't. Comment down below, the usual YouTube stuff. Huge thanks to my supporters, you know, all that stuff. And yeah, I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.